Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about the last algorithm in disk scheduling, that is CLOOK algorithm, right? Let me tell you what is this CLOOK algorithm. It is similar to scan algorithm. So that is the first point we started, how this DISCOM is positioning from left to right, right to left, and serving all the paths or whichever it is, right? So here the CLOOK, it is also similar to CLOOK, right? This CLOOK is very similar to the previous algorithm, and here the CLOOK is all about the discom in spite of going to the end, and it stops exactly at the request. Say for example, it starts with 50 and it ends with 190, right? And then when it is reversed back to this particular least values, it is not stopping, it is not stopping and serving anywhere in the middle, and it will stop exactly at the last least value, that is 16, and from there it starts again, it serves to 24 and 43, right? So that is the only difference here, but here it is, this particular algorithm is actually used to prevent the extra delay which occurred due to the unnecessary traversal to the end point of the disk, that is 0 and 199. So I hope you understand how this works. Let's get into the topic directly. Right now I'm going to just prove with this example so that you will understand very clearly what I explained theoretically. So here it is, request is 50, 82, 170, 43, 140, 24, 16, 90. The same example we have used for all 5 previous algorithms. And the arm exactly stops at 50. Here it was clearly given towards the larger value. So exactly this position of this header is exactly at 50. So we have this 50 exactly here, the header is at 50. Now it is going to traverse, it is a scan, right? It is not stopping anywhere in between. It will stop exactly at the last positioned value, that is the highest request we have given, it is 190. So it is not stopping anywhere, it will stop exactly at 190 here. Now in the path between 50 to 190, the same explanation I explained for this 3 previous scheduling. It serves 182, that is 82, and it serves 140, and it serves 170. Anything else I missed? And it is stopping exactly on 190, and it is serving this 190. So it is not moving towards after 190 because there is no more service has been provided, no more request has been provided after 190. So it is not traversing forward, it will reverse back, right? It will reverse back to this last position, that is not 0, that is last position is 16. So here the last least number is 16. So in between it is not serving anything. That is the only difference between this algorithm and the previous one, look and CLOOK. So here it stops exactly at 16. The service has been made in 16, and then it will reach to 24. The 24 request has been already given. You can check it over here. 24 is there. So request has been served, and it is not stopping exactly here. It stopped only at 43. So here we can check that the sequence of serving 1, 2, 3, 4, and this is 5, this is 6, this is 7, right? So totally all this request has been served now. But what is the sequence of head movement, where it starts and where it ends? We are going to draw that head movement. It starts at 50 and it ends exactly at 199. This is the first sequence of head movement, right? Second sequence of head movement, it starts exactly at 199, and all these dotted lines is all about where this header has been started and where it is ending. This is number 2, and again it starts at 16 and it ends at 43. So this is number 3. So we have totally 3 stops: 50 to 199, 199 to 16, 16 to 43. So this is the only have processing head sequence of reaching the distance, so that we are going to calculate the total distance covered by a discom, right? This is the final algorithm. Let's check whether it is giving the smallest throughput value, so that we have to consider as the highest one, right? Reduce the process of understanding. So here it is, disk arm is equal to, that is total distance covered by this particular disk arm, that is equal to the first sequence. So 50 to 199. So the same sequence I am going to mention, 199 minus 50 plus the second sequence, that is it starts again from 190 to 16. So here it is 190 minus 16. So that's a point. So finally we have one more thing, that is third sequence of head movement, that is 16 to 24. So here it is, sorry, not 24, 43, 16 to 43. See here the 43 and it is ending exactly at 43. So 16 to 43, in the sense we are going to calculate that as 43 minus 16. So 149, 180 pros 174, 300 and yes 341. So now I'm going to mention this is the total distance covered by a disc arm. So that is totally we have 341. So now let me tell you how this C-look is different from the previous algorithm, that is look is different from the C-scan, and C-scan is different from the scan, and scan is different from the previous algorithm called that is FCFOs and shortest seek time first. So this is all about, you need to understand which particular algorithm among 6 has given the better total distance disc arm, that should be shorter. If it is shorter, that algorithm choose to be a best algorithm for accessing all this part of data symptoms and the data access procedures in dish scheduling algorithm, right? So now continuously we have a random scheduling also here, but we are not getting into the point for us. And random scheduling is there, last in first out is there, n step scan is there, f step scan is also there. But up to this particular algorithm, we are very much discussed about how this dish scheduling algorithm is actually working. I hope you understand how the C-look algorithm is actually working, right? So thank you for watching this video. Have a great day.